Okay, all right. So now let's look at this example. Okay, so we have two variables. Okay, so we look at here, we have two independent variables, right? Which is x and y. And one dependent variable, which is here for this one is z lah. Z which is equal to the f as y. Alright, okay, so now we want to determine the domain. Okay, so when we say it is a domain and it's involved two independent variables, meaning that we will have two axes. Because two independent variables, so it will be two axes. Okay, so what are the axes? X and y. Okay, so in this case, we need to ask, is there any restriction on this function x plus y? Okay, is there any restriction on that? Okay, x can be any number and y also can be any number, isn't it? Okay, so meaning that for this one, the domain, okay, so we put as d, the function of f. Okay, so we determine what are the independent variable. Yes, it is x and y. Okay, such that, okay, what are the restriction? Is there any restriction? No, there are no restriction, but it can be any number. So meaning that x and y can be any real number. Okay, so there are no restrictions such that x and y can be any number. So that is our domain. Okay, that is how we describe the domain. Okay, so how about the range? Okay, just now we have no restriction on x, no restriction on y. Okay, so x and y can be any real value R. Okay, so now what would be the range? Okay, so in this case, what would be the range? Range of f, which is range for the z here. Okay, if we look at the graph, okay, can be any restriction on the z as well. Okay, z can basically in this case, okay, range, okay, where rf we define as this. Okay, what is the variable inside the f? Yes, it is z. Okay, so for this case, z also can be any real number. Okay, there are no restriction for that. Okay, so if we sketch the graph, okay, so it's x plus y. Okay, we take it x plus y equal to 0, so x equal to y. Okay, so this is the graph. X is, okay, so x, so you just leave it, okay, so what y equal to negative x. Okay, so what is the slope? This negative 1. Okay, so it will be here. Okay, so if you want to sketch the region, okay, basically if we consider the x and y axis here, so let's a surface here, so it can be any number, any real number. So the region is can be any point. Okay, meaning that can be any point on the surface. Okay, all right. Okay, so next, let's look at the next example. Okay, so we have f as y equal to x squared minus y. Okay, so now we have square root. Okay, so now we have the square root. Okay, is there any restriction for the square root? Okay, so we need to think about that. Okay, so before that, what is the independent variable in this case? Yes, it is x and y. Okay, what are the dependent variable in this case? Okay, we only have one, which is z. Okay, all right, since we have two independent variables, so we will have two axes. Okay, so basically it's 2D, two axes. Okay, which is axis x and y. Okay, so is there any restriction for the third? Yes, of course. The square root, okay, the value inside the square root cannot less than 0, meaning it cannot be negative. Okay, but it can be 0, right? Okay, therefore, what you can say is x squared minus y must be greater or equal to 0. Okay, x squared minus y greater or equal to 0. Okay, so how we want to sketch this? Okay, so we just rearrange this one. Okay, can be negative x squared, so y is less or equal to x squared. Okay, therefore, what would be the range? What would be the domain here? Okay, the domain consists of x and y such that y must less or equal to x squared. Alright, so this is the domain. Okay, this is the domain. Okay, so now how I want to sketch the graph? So in order to solve this, okay, so we just take it as y equal to x squared graph. Okay, so this will be the graph x and y. Okay, alright. So how we want to sketch the region? Okay, so in order to sketch the region, okay, so we will choose any test point. Okay, so that is fulfill the domain. Okay, so for example, let's say we choose value of 1, 1. And another one, or we choose value of 0, 1 here, 0, 1, or we choose 0, negative 1. Okay, so the region could be at the top or at the bottom. So we just try to look at this one. Okay, is it fulfilled? Okay, so we have y equal less or equal to x squared. Okay, so for y, we choose the first one here first. Okay, y is 1 less or equal to 0 squared. Is it correct? No. Okay, so it's not equal. Okay, so how about the second point here, second test point? Okay, so second test point here is, okay, y is negative 1. Is it less or equal to 0 squared? Yes. Okay, so meaning that it's fulfilled. Okay, so we can say here the region for this function is at the bottom here. It can be any point down here. Okay, alright, that is the region for y less or equal to x squared. Okay, for this domain. Okay, so now what would be the range? What would be the range for this? Okay, just now we have it can be any point for y that less or equal to the x squared. Okay, alright. So how about the, let's use the different color. Okay, how about the range? Okay, so how we want to think about the range? Okay, so the range we can define as R. Okay, so what is the variable? Is Z. Okay, such that, okay, for this case, y less or equal to x squared. Okay, so we know that the Z must be positive. Okay, because this is the value of Z, right? Okay, so Z is equal to the x squared minus y. So Z must greater or equal to 0. Okay, so the whole thing here must be greater or equal to 0. That is the value of Z, isn't it? Okay, but basically Z can be any point, so the minimum point is 0. Okay, so it can be any number. Okay, but the Z must greater or equal to 0. Okay, alright. Okay, it fulfill this. Okay, since it's square root here, we have the square root there. Okay, and the number must greater than equal to 0, because the x minus y inside here always greater or equal to 0. Therefore, the square root of that also greater or equal to 0. That is the range. Got it? Okay. Alright. Now, let's look at the next example. Okay. This one. Okay. So, if we have x squared plus y squared set. Okay. Alright. So, we have the independent variable, which is x and y. Okay. We have dependent variable, which is z. Okay, alright. So now, is there any restriction for fxy here? Okay, yes. Okay, x squared plus y squared must always greater or equal to 0. Okay, because the set, right? Okay, but now, of course, any value of x always can be greater or equal to 0. Why? Because it's squared here. So we have the squared. We have the squared here, squared here. So if the value of x is negative, you still get positive value. If the y also negative, can be and then it's squared, it will be positive also. Okay. So meaning that in this case, what will be the domain? Okay. So x, y, okay, such that, okay, so basically, yes, x squared plus y squared is always equal, greater or equal to 0. Okay, even though we don't have any restriction, it's always greater or equal to 0. Okay, so in this case, we can say x and y is all a real number. Okay, if you pick any number, always fulfill greater or equal to 0, right? Okay, therefore the domain for this one is all real number. There are no restriction. Yes, no restriction because x squared plus y squared is always positive. Okay, alright, therefore, how about the range? Okay, so therefore in this case, the range also must greater or equal to 0. Okay, because the minimum value is 0. Okay, if we take any number, the minimum value is 0. Okay, therefore z is greater or equal to 0 because we have the set. Okay, can